Hi, and welcome to a quick overview of the area of a trapezoid. I know that we've been playing around with this trapezoid shape here, and basically remember a trapezoid is a four-sided shape where it only has two parallel sides. These sides here, they're not going to be parallel, which means that they can intersect somewhere off in space at some point. It doesn't matter what those angles are, it's still a trapezoid. Now, we've been playing around with these shapes a little bit, and we've been playing with composite shapes and how shapes are put together by other shapes. And that's an idea that's going to help us to solve the area of this trapezoid. So this is a little bit harder to get the area just by looking at this off the bat. So what we can do is we can pretend that this is made of other shapes. And I'm going to do an old trick that we have with any four-sided shape. If I connect the opposite sides, I end up getting two triangles. And that's really going to help us to figure out what the area of this whole shape is. So one of the things we have to realize is that the height of these two triangles is going to be exactly the same. And when I mean the height of the triangles, what I mean is the distance from the peak to the base. And I can prove that those are the same sizes because I can take this line and I can move it anywhere on this trapezoid and the distance doesn't change. So even if I were to measure the height off of the shape, I know that that height is going to be the same inside of that shape as well. And I can just take this line and move it around. So no matter what I'm looking at, the height of that trapezoid is going to be the same for both of those two triangles. Now, what I want to look at now is putting these two triangles together in order to solve the area. So I know that the area of one triangle is going to be, well, let's just call this base 1, and we'll call this guy up here base 2, because those are the different bases for the different triangles. Even though the height is the same between them, you can see that this baseline is going to be different, and those have to be our bases because they're 90 degrees to our height. So I know if I was looking for the area of, let's say, we'll call this triangle 1, I was looking for the height of triangle 1, I know it's going to be base 1 multiplied by the height, and then I still need to divide by 2. So that's the area of that one side. If I was going to get the area of the other side, I'm going to do the same sort of idea. However, instead of using base 1, I need to use base 2 because the second base is a different size. So the area of that triangle is base 2 multiplied by the same height and divided by 2. Now, as you can see, when I brought those things across, the only thing that's different between those two is going to be the base 2 and the base 1. So I could take these and put them together and say that area is going to be equal to base 2 times height plus base 1 times height. And of course I can do those in different orders. I can take them and I can just move them around and put them in a different order. Just like that. That makes more sense because I've got the 1 before the 2 now. But when I do look at that, I know that I've got things here that are the same. For instance, height and 2, those are exactly the same. And so what we end up doing with our formula for the area of a trapezoid is we take it and we change it and we use some algebra and we say the area is equal to, and now we've got our parentheses, which means to do this first, I've got to take the length of the first base, I've got to add it to the length of the second base, and after I do that, I can multiply that total times the height, and then I'm going to take that total and I'm going to divide it by 2. So then we get our general formula for the area of a trapezoid is going to be area is base 1 plus base 2 multiplied by height and then divided by 2. Hope that helps. If you have any questions, just see me.